Lesson 5B deals with operations with complex numbers. Up to this point, we've only been working in the real number system where you talked about whole numbers, integers, rational numbers, counting numbers, and things like that. But there's actually another system called the imaginary number system, and that deals with the square roots of negative numbers. They don't exist on an actual plane, but you can still solve quadratic equations using the imaginary number system. Mainly what you need to know is that the number I represents the square root of -1. So the imaginary number system is completely revolved around the fact that the square root of -1 is now equal to I. Since you can't take the square root of a negative number in the real number system, mathematicians created the imaginary number I. What you need to keep up with here is the 4 powers of I. I is equal to the square root of -1. I squared would be I times I, which would be the square root of -1 times the square root of -1. We know the square root of anything times itself is just what's under the radical, so I squared gives you -1. I cubed would be I times I squared, which is -1 times I, giving you -I. And then I to the 4th would be I squared times I squared, which is -1 times -1 is equal to 1. Now the only reason you have to keep up with the first 4 is because if I took this a step further and I asked you to find I to the 5th, then that's going to be I to the 4th times I to the 1st. This we just established is 1, so that would just be I, and you start repeating the pattern over again. So if somebody asks you to find I to the 50th, for example, what you want to do is pull out how many sets of 4 you can. So you're going to pull out 4. How many times does 4 go into 50? 12 times. So that accounts for 48, which is going to leave you with 2 more. All of this is equal to 1. So then you're left with I squared, which you can simplify to be -1. So all the rules of I work around just the 4 exponents of it. Now the complex number system is a combination of the real system with the imaginary. We always write it as A plus BI. Notice the A is the real number part, the BI is the part that contains the imaginary. And we can do all kinds of mathematical operations within the complex number system. You can add, subtract, multiply, divide. When you're adding, you just simply combine your real numbers. That's why we're going to combine the A and the C. And then you combine your imaginaries, the A and the D, and you keep it with the imaginary I. The difference, you just subtract your A and your C, and you subtract your B and your D, and you keep that with the imaginary I. The complex number system for multiplication is just revolved around the distributive property or FOIL method. So here we're going to do our first, and then we're going to do our outer, and then you do your inner, and then you do your last term. So all you see here is the FOIL system that you guys learned in Algebra 1. And then you would put your imaginaries together. And remember, I squared was -1. So this BD term, which was positive, is going to become negative. If it was negative, it's going to become positive. And then these guys can be combined together because they don't have an imaginary term, so they belong to the real number system. And then the middle terms did have an I, so they belong to the complex number system. Dividing, the way you divide complex numbers, we don't like to have square roots in the denominator. And I, in essence, is the square root of a -1, so it's like having a square root in the denominator. So the way you get rid of it is multiplying by the conjugate. And the conjugate is literally the exact same thing you had, you just change your sign. So if you have A plus BI, you would multiply by A minus BI. If you had 7 plus 6I, you multiply by 7 minus 6I. And through the FOIL method, what happens there is your imaginaries go away, and you would just be left with a numerical term on the bottom. But to be fair, whatever you do to the top, you have to do to the bottom, because this in essence is just 1. So that's why the top needs it as well. Well, we'll do some examples with that. Okay, so here's an example of adding and then an example of subtracting. First thing we're going to do is combine our 6 and our 5. So we have 6 plus 5. We're going to group those together because they are part of the real system. And then we are going to group our imaginaries together. So we have negative 3i and grouped with positive 4i. So once you figure out who you're working with, go ahead and simplify that. That's going to give us 11 plus 1i. Same thing for subtraction. You want to combine your 8 and your minus your 8. And then we've got our 20i minus our negative 9i. So what we have here is 0 plus 29i, which you don't have to write the 0, so you can just express that as 29i. If you do, it's not wrong, but it's not necessary. Okay, so that's adding and subtracting. Multiplying, we're going to, since this is, you can only FOIL a binomial times a binomial, so this would just be the distribution. So we have 6 times 3 is 18i. And then you have 6i and 2i give you 12i squared. Remember from the first screen that I squared is equivalent to negative 1. So that's going to give us 18i. Since this is negative 1, that's going to make that a minus 12. Which typically we're going to write that as negative 12 plus 18i. Because complex form has the real part coming before the imaginary part. Okay. So this is, we're going to do the FOIL method. So we're going to do our first terms. Get negative 20. Do your outsides, negative 15i. Do our insides, positive 28i. And then your last give you a positive 21i squared. So then remember, I squared is negative 1, so we have negative 20 plus 13i. And then this is going to be minus 21. So you would say negative 41 plus 13i. Okay, so that's multiplying. Dividing is going to be similar to multiplying. So you see that you have a radical in the denominator because of the I. So you have to find what the conjugate is. So the conjugate of 2 minus 3i would be 2 plus 3i. But we can't just go around giving terms to one part of a fraction. So we got to make this equivalent to 1. So we need to put the same thing on the top, because anything over itself is equivalent to 1. So now we've got to FOIL the top and FOIL the bottom. When we FOIL the top, we're going to get 14 plus 21i plus 8i plus 12i squared over, and when we FOIL the bottom, we're going to get 4 plus 6i minus 6i minus 9i squared. And the reason we do the conjugate is the conjugate will always cause those middle terms to cancel out. Remember, 12i squared is the same thing as negative 12. So 14 minus 12 is 2 plus 29i. And remember, negative 9i squared would be the same as positive 9, so 4 plus 9 would give you 13 here. And if you had a common factor between these three terms, you would try to reduce it, but we don't. So we're done. Okay? Over here, it's kind of hard to do the conjugate of 12i. So you just need to multiply by 12i. Can't do a conjugate of a monomial. So just multiply it times itself. We'll do 12i up here. So 4 times 12i is 48i. 9i times 12i is positive 108i squared. And on the bottom you've got 144i squared. Remember, I squared is just negative 1, so that's negative 108 plus positive 48i. And on the bottom, again, the I squared just becomes a negative 1. That gives you negative 144. You always want to simplify your answer as much as you can. So you want to ask yourself, what's the smallest number that can go into 108, 48, and 144? And so just mess around on your calculator for a second. So 48 doesn't work. So you might want to try 24. 24 doesn't go into 108. So let's just try 6 for a second. I don't know if that's going to get us all the way there. So that's going to give us negative 18 plus 8i over negative 24. So I should have gone with 12. So I'm going to divide all this by 2 again, and so I'm going to get negative 9 plus 4i over negative 12. You might also see that as 9 minus 4i over 12. That's working with complex numbers. You'll use this when we're doing the quadratics, because when you go to take the quadratic formula, you might be left with a negative radical, and you're going to bring I into your answer as well. So that's kind of why we're doing this now.